Okay, so this is the homework 62. Okay, not 63, it's 62. And this is basically acid base. This is buffer reaction. Number one is easy because all this is asking you is to find ratio of the um, the ratio of the acid to base that you need to maintain the pH of the buffer that has the pH is equal to 5, right? So easy. You know the pKa of acetic acid. This is the pH that you want. And then just plug everything in, subtract 5 by 4.74, so you have 0.26. Okay, so and then take out the log, so you have the ratio of the uh, base over the acid. It is per every 1 mole of the acid, you need 1.82 mole of the base. And then if you want to prepare the solution, you just weigh out 1 mole of acetic acid and then 1.82 mole of sodium acetate. And that's pretty much it for number one. Okay, number two, there's two questions here. You have the reaction between formic, you have the buffer, okay, of the formic acid, okay, and then you have the formate. Sorry, let me erase this. Okay. So you have formate, so COOHCOO. Okay, so now before you start the reaction, before you add this hydrochloric acid, you want to find the pH. That's easy because you just find the pKa of formic acid, plug in the concentration of the base, plug in the concentration of the acid, and then you have your pH 3.89. Now, what if you add acid to this buffer? What happened? Now, because the acid that you add will react with the conjugate base, right? And then it changed back to acid. So now the question is that how much acid did you add? You have 10 milliliter, and then this is the concentration. This is the mole of H plus that you're adding. So what does this H plus do? Again, it goes react with the conjugate base and become acid. So that means at the end, the concentration of the acids has to increase. By how much? By the same amount of the acid that you add. So this is the mole of the acid that you have originally, formic acid. Okay, and this is the amount of formic acid that formed from the reaction of formate ion and H plus. So at the end of the reaction, this is the amount of the acid, formic acid that you have. Now the formate, because some of the formate has to react with H plus, so some of it will deplete. This is the amount of the formate ion you have originally before you add HCl. Some of it has to react with the HCl by this quantity. So this is the amount of formate ion that you have left at the end of the reaction. So you plug this in, okay, base over acid, and you have the pH that is equal to 3.86. You see the pH doesn't change that much. Next one. What is the pH of after you add 25 milliliter of 0.1 molar base hydroxide to 50 milliliter of HCl? What happened to the pH after 50.5 milliliter of sodium hydroxide has been added? Okay, so let's see over here. Okay, this is what you have in the flask. This is the amount of acid that you have, and this is the amount of the base that you added. You see that base is limiting, so at the end you're gonna have this quantity of HCl left. So now, how do you find the pH? Now, remember, if you want to find the pH, you have to find the concentration. You cannot use the mole. So the concentration, how you find the concentration? The mole that you have over here, divide by the total concentrate, the total volume of the solution. This is your the concentration of H plus. Plug it in here, pH 1.176. Now, what if you add too much of the base? Okay, like went beyond the equivalence point. So now hydroxide becomes excess reactant, and then this is what you have left at the end. You don't have any H plus left. So divide the concentration of the hydroxide by the total volume. And then you have POH and then pH. And that's it for number 4. Number 5, what is the pH of solution when you added 35 milliliter of sodium hydroxide to this acid? Okay, this is the weak acid now. Find the mole of the hydroxide first. Volume multiplied by the concentration. This is the mole of the hydroxide you added. And then this is mole of the acetic acid that you added. So let's see what happened. You have acetic acid, excess hydroxide is the limiting reactant, right? So that means that all of this will be gone. You don't have any hydroxide left. This is amount of acetic acid you have left. This is the acetate. This is buffer, right? Because you have weak acid and conjugate base. Plug in acid over here. Oh no, sorry. Did I do this wrong? Oh yeah, I did it right. Okay, so base goes over here. Sorry, acid goes down here. So pH that I have is 4.47. Number 5, describe how to prepare the buffer solution between ammonia and ammonium chloride. You know the pH, this is pH that you want. pKa of ammonium is 9.25. Yeah. And then subtract 9.25 by 9.5 by 9.25, and then take out the log. This is the ratio that you have. So add this many mole of ammonia per every 1 mole of ammonium chloride. And that's it. Okay. Number 6, which of the following would be the best choice for a buffer that has pH approximately 7? So you have to look at which acid base pair which acid has the pKa that is close to 7. Not this one, because the pKa of phosphoric acid is too low, 2.12, and then pKa of the hydrogen phosphate is too high. So the pKa of this acid is close to 7, so your answer is going to be B. Number 7, which of the following combination would be the buffer with a pH approximately 9? This is not even a buffer, right? Now the pKa of this is too low, 4.74. Then this one, ammonium, has a pKa of 9.25, so your answer is B. Number 8, what happened to buffer when a small amount of strong acid is added? You added acid, right? So that means that the conjugate base where we have to react with H plus become this. So that means that this ratio will decrease. Okay, so that means that this value become smaller. Okay, so that means that the pH will increase slightly. Number 9, if you dissolve 0.429 grams of hydroxide to 2 liters, okay, and then to have a buffer solution, and then the concentration of these two are the same, what is the pH of the solution before adding hydroxide? Before adding, you just plug in the values. Okay, so this is the concentration of the acid and base. So this is essentially equal to 0. So pH is equal to pKa, 7.21. So this is the amount of hydroxide that you added. Find the mole, okay, divide by volume. This is the molarity of the base that you add. So when you add base, what does it do? This hydroxide will react with the acid and then change it to base. So that means that the acid concentration of the acid will decrease, and the concentration of base will increase by that quantity. And then find this value, add it to this, and then the answer is 7.24. Number 10, what would be the change when 20 milliliter of 0.1 molar hydroxide added to 80 milliliter buffer solution? Okay. Wait, it's running out of time. I'm going to have to continue with the second one, okay?